In September 1977, humanity launched a small spacecraft into the darkness of space. We called it Voyager 1. Back then, disco was still alive, bell-bottoms were in fashion, and the idea of a phone that could fit in your pocket was pure science fiction. That little probe was supposed to study Jupiter and Saturn, take some pictures, send back data, and then quietly fade into the cosmic void. Its primary mission was expected to last just 5 years. 5 years. That's it. But here we are, nearly half a century later, and Voyager 1 is still out there, still sending signals back to Earth from a distance so vast that light itself takes more than 22 hours to make the journey one way. It's the farthest human-made object from Earth, sailing through a region of space that no other spacecraft has ever reached. But lately, something strange has been happening. The signals coming back from Voyager 1 have been getting weird. Sometimes they make no sense at all. Sometimes they stop completely. And this raises a question that sounds like something out of a science fiction movie. Is Voyager 1 still functioning properly, or are we just receiving the electronic echoes of a machine that's already dead? Are we talking to a living spacecraft, or are we talking to a ghost? To understand what's happening with Voyager 1 right now, we need to understand just how remarkable this machine really is. When NASA designed Voyager 1 and its twin, Voyager 2, they built them with technology from the early 70s. The computer on board Voyager 1 has less processing power than a modern digital watch. The entire spacecraft has about 68 kilobytes of memory. Your smartphone has millions of times more computing power. The cameras on Voyager used technology that was already becoming outdated when the spacecraft launched. But despite all these limitations, Voyager 1 accomplished things that still amaze us today. It gave us the first detailed close-up images of Jupiter's swirling storms and discovered active volcanoes on Jupiter's moon Io. It revealed the intricate structure of Saturn's rings in breathtaking detail. It found new moons we never knew existed, and then, after completing its primary mission, it just kept going. It didn't stop, it didn't quit, it sailed on into the outer solar system, past the orbits of Uranus and Neptune, past the distant realm of Pluto, heading toward the edge of our sun's influence. In 2012, Voyager 1 crossed a boundary that no human-made object had ever crossed before. It entered interstellar space. This doesn't mean it left the solar system entirely, because technically the solar system extends far beyond where Voyager is now, all the way to the outer edge of the Oort cloud, which is still thousands of years of travel away. But Voyager 1 did cross the heliopause, the point where the solar wind from our sun can no longer push back against the pressure of interstellar space. Beyond this boundary, the spacecraft entered a realm dominated not by our sun, but by the environment between the stars. It became, in a very real sense, an interstellar traveler. And it's still sending data back to us. Every day, Voyager 1 transmits information about this alien environment, telling us what it's like in the space between stars. The signal is incredibly weak. By the time it reaches Earth, the power of Voyager's transmission is about 20 billion times weaker than the power needed to run a digital watch. NASA uses some of the largest and most sensitive radio dishes on Earth to catch these whispers from the edge of known space. The spacecraft is so far away that even traveling at the speed of light, the signal takes over 22 hours to get here. If you sent a command to Voyager 1 right now, you'd have to wait nearly 2 days to find out if it worked. But here's where things get truly unsettling. Over the past few years, Voyager 1 has started acting strangely. In May 2022, engineers at NASA noticed something wrong with the data coming from the spacecraft's Attitude Articulation and Control System, the AACS. This is the system that keeps Voyager 1 pointed in the right direction, making sure its antenna stays aimed at Earth. The telemetry data from this system, the information that tells engineers what the spacecraft is doing, started coming back garbled. It was as if the AACS was sending back random numbers, information that didn't match what the spacecraft was actually doing. Yet somehow, despite these nonsensical readings, Voyager 1 was still properly oriented. Its antenna was still pointed at Earth. The signal was still coming through. It was like talking to someone who tells you they're lost and confused and have no idea where they are, but they're standing right in front of you, looking you straight in the eye. The situation made no sense. Engineers spent months trying to figure out what was happening. They sent commands into the void, waited 2 days for responses, analyzed the data, formed new theories, sent new commands, and waited again. This slow-motion conversation with a machine billions of miles away continued for months. Eventually, they figured out that the AACS was sending its data through a computer that had stopped working years ago. Why it suddenly started doing this, nobody knows. But they managed to redirect the data flow, and for a while, things seemed okay. The crisis appeared to be over. Voyager 1 was back to normal, or at least as normal as a 46-year-old spacecraft could be. But then, in November 2023, something worse happened. The spacecraft stopped sending readable data entirely. Instead of coherent information, Voyager 1 started transmitting what looked like gibberish, a repeating pattern of ones and zeros that meant absolutely nothing. It was as if the spacecraft had suffered a stroke, still alive, still transmitting, but unable to form coherent thoughts. Engineers at NASA's Jet Propulsion Laboratory found themselves staring at screens filled with meaningless data, knowing that whatever had gone wrong was happening 12 billion miles away, and any fix they attempted would take nearly 2 full days just to reach the spacecraft. The problem turned out to be in the Flight Data Subsystem, the FDS, which is responsible for packaging the science and engineering data before sending it to Earth. About 3% of the FDS memory had become corrupted. Just 3%. A single chip had failed, but that tiny failure was enough to render the entire data stream unreadable. Think about that for a moment. A computer chip sitting in the frozen darkness of interstellar space, bombarded by cosmic rays for nearly 50 years, finally gave out. And when it did, it threatened to end our communication with humanity's most distant ambassador. The engineers faced an enormous challenge. They couldn't just reboot the system or upload a patch the way you might fix a computer here on Earth. Every command took 22.5 hours to reach Voyager. Every response took another 22.5 hours to come back. And they were working with a computer that was designed with technology from the 1970s, with extremely limited memory, running software that had been modified and patched countless times over nearly 5 decades. They had to find a way to work around the corrupted memory without causing any other systems to fail. In April 2024, they succeeded. They managed to relocate the affected code to a different part of the FDS memory and modify it to work in its new location. The process was delicate, precise, and required an intimate understanding of a computer system that was older than many of the engineers working on it. When the fix finally took hold and Voyager 1 started sending readable engineering data again, it was a moment of profound relief. The spacecraft had been brought back from the brink. But even as NASA celebrated this success, the incident raised deeply unsettling questions. How many more of these failures are coming? How many more chips are on the verge of dying? How much longer can this spacecraft possibly survive? Voyager 1 is powered by 3 radioisotope thermoelectric generators, RTGs. These devices convert heat from decaying plutonium into electricity. When Voyager launched, its RTGs produced about 470 watts of power. But plutonium decays over time, and as it does, the power output gradually decreases. Today, almost 50 years later, the RTGs produce only about 220 watts. That's barely enough to power a few light bulbs, and the power keeps dropping, about 4 watts per year. NASA has been turning off systems to conserve energy. Over the years, they've shut down the cameras, heaters, and various scientific instruments. Every few years, they have to make another difficult decision about what to turn off next. Each time they power down another system, Voyager 1 becomes a little less capable, a little closer to the end. Current estimates suggest that by the mid to late 2030s, there won't be enough power left to run any scientific instruments at all. The spacecraft might still be able to maintain basic communication, but it won't be able to tell us anything useful about the environment it's traveling through. And even that limited survival depends on nothing else breaking. The recent failures have shown just how fragile Voyager 1 has become. The spacecraft was built with redundant systems for critical components, but those backups are now just as old as the primary systems. When something fails, there isn't always a backup available anymore. Some components have lasted far longer than they were ever designed to last, operating under conditions they were never tested for. Consider the environment Voyager 1 is operating in. The spacecraft is in interstellar space, where temperatures hover around -270 degrees Celsius, just a few degrees above absolute zero. It's constantly bombarded by cosmic rays, high-energy particles that can corrupt computer memory, damage electronics, and degrade materials. There's no atmosphere, no protection, nothing between Voyager and the harsh radiation of deep space. The fact that any of its systems still work at all is frankly miraculous. But cosmic rays aren't the only threat. The spacecraft is also affected by something called bit flips, random changes in computer memory caused by radiation. A bit flip can turn a 0 into a 1, or a 1 into a 0 in the spacecraft's memory, potentially corrupting critical data or code. Most of the time, these bit flips are harmless or get corrected by error-checking systems. But occasionally, one hits just the wrong spot, and you get a situation like the corrupted FDS memory that caused the recent crisis. There's also the simple reality of mechanical wear. Voyager 1 has thrusters that fire occasionally to keep the spacecraft properly oriented. These thrusters have been operating for nearly 50 years, far longer than they were designed to last. They're starting to degrade. The thruster tubes are clogging with silicon dioxide, a residue that builds up over time. In recent years, NASA has had to switch between different sets of thrusters as the primary ones become less efficient. Eventually, all the thrusters will degrade to the point where they can't maintain the spacecraft's orientation, and when that happens, Voyager 1 won't be able to keep its antenna pointed at Earth. The signal will be lost forever. So when we talk about whether Voyager 1 is still alive, or whether we're talking to a ghost, we're really asking a deeper question. What does it mean for a spacecraft to be alive? Is it still alive if it can send a signal but can't send useful data? Is it alive if it's functioning but slowly dying, system by system? At what point does a spacecraft cross the line from living to dead? These questions might sound philosophical, but they have practical implications. Every time NASA receives a garbled signal from Voyager 1, engineers have to decide whether it's worth the effort to diagnose and fix the problem. They have to weigh the scientific value of keeping the spacecraft running against the time, money, and resources required to maintain it. They have to consider the possibility that the next failure might be the one they can't fix, the one that ends the mission permanently. And there's another factor to consider. The people who built Voyager 1, the engineers who knew every circuit and every line of code intimately, are retiring or passing away. The institutional knowledge of how Voyager really works is slowly being lost. Today's engineers have documentation, but documentation can't capture everything. There are tricks and workarounds, undocumented modifications made over the years, knowledge that exists only in the minds of people who are no longer around. Every time something goes wrong with Voyager, there's a risk that the solution might depend on knowledge that no longer exists. Yet despite all these challenges, despite the failing components and the dwindling power and the corrupted memory, Voyager 1 keeps going. It keeps transmitting. It keeps fighting. And in a strange way, that persistence tells us something profound about human nature. We built this machine to explore, to push boundaries, to go where nothing had gone before. And we built it so well, with such care and such redundancy, that it's still doing its job half a century later, long after it was supposed to die. When we look at what Voyager 1 has accomplished, it's easy to forget that this spacecraft was never supposed to last this long. Its primary mission was 5 years. Everything after that has been a bonus, an unexpected gift. The fact that we're still receiving any signals at all from interstellar space is extraordinary. The fact that those signals occasionally contain useful data is almost unbelievable. But the recent failures remind us that this can't last forever. Every signal from Voyager 1 could be the last one. Every successful fix might be followed by an unfixable failure. The spacecraft is living on borrowed time, operating in an environment it was never designed for, with components that are far past their expiration date. We're watching a slow-motion death, stretched out over years and decades, played out across billions of miles of empty space. Some scientists have started thinking about what happens when Voyager 1 finally goes silent. The spacecraft will keep moving, of course. It doesn't need power to coast through space. In about 40,000 years, it will pass within about 1.5 light years of a star called AC plus 79 degrees, 3,888 in the constellation Camelopardalis. It won't stop there. It will just keep going, drifting through the galaxy for millions or billions of years. Attached to the spacecraft is the Golden Record, a disk containing sounds and images from Earth, a message to any alien civilization that might someday find it. Voyager 1 will carry that message through the cosmos long after humanity itself might be gone. But for now, While we can still communicate with it, every signal from Voyager 1 is precious. Every piece of data it sends back tells us something we didn't know about interstellar space. The spacecraft is measuring the density of plasma, the strength of magnetic fields, the intensity of cosmic rays. It's giving us our first real look at the environment between the stars, the ocean of space that our descendants might one day have to cross if we ever hope to reach other star systems. And here's something that's both beautiful and terrifying. Voyager 1 is currently traveling at about 38,000 miles per hour relative to the Sun. That sounds incredibly fast, and it is by human standards. But space is so vast that at this speed, it would take Voyager 1 about 75,000 years just to reach the nearest star system, and it's not even headed in that direction. The distances involved are almost incomprehensible. Voyager 1 has been traveling for nearly 50 years and has barely left our cosmic doorstep. This puts the recent technical problems in perspective. We're trying to maintain communication with a fragile, aging spacecraft that's farther away than anything humanity has ever built, traveling through an environment we barely understand, using technology that's older than most people alive today. The fact that it works at all is astonishing. The fact that we can still diagnose problems and implement fixes across 12 billion miles of space with a 2-day communication delay is a testament to human ingenuity and perseverance. But it's also a reminder of our limitations. Despite all our technology, despite all our knowledge, we can't protect Voyager 1 from the ravages of time and space. We can't replace its failing components, we can't add more power, we can't shield it from cosmic rays. All we can do is watch, listen, and try to keep it going for as long as possible. The engineers at NASA have developed a deep, almost emotional connection with Voyager 1. They talk about the spacecraft with a mixture of pride and affection, the way you might talk about an aging parent or grandparent who's still sharp and capable despite their years. When something goes wrong, they don't just see it as a technical problem to solve. They see it as a crisis, a threat to something precious and irreplaceable, and in a sense, they're right to feel that way. Voyager 1 is irreplaceable. We could build another spacecraft with modern technology that would be faster, more capable, more efficient, but we can't recreate the historical significance of Voyager 1. We can't recreate the fact that this particular machine, built with 1970s technology, has traveled farther than any other human creation. We can't recreate its journey, its discoveries, or its place in history. So when we ask whether Voyager 1 is still alive, or whether we're talking to a ghost, maybe we're asking the wrong question. Maybe the right question is not about the state of the spacecraft, but about what it represents. Voyager 1 is more than just a machine, it's a symbol of human curiosity, human ambition, and human persistence. It's a reminder that we're capable of creating things that outlast us, that transcend us, that carry our hopes and dreams into places we can never go ourselves. Every signal we receive from Voyager 1, whether it's clear data or garbled nonsense, is a voice from the edge of the known universe. It's a message from interstellar space, from a region no human will visit in our lifetimes, or probably for many generations to come. It's proof that we can touch the stars, even if only with the electronic whispers of an aging spacecraft. But the clock is ticking, the power is running out. The components are failing, and someday, probably within the next decade or two, we'll send a command to Voyager 1 and hear nothing back, or we'll receive a signal that makes no sense, and this time, we won't be able to fix it. Or the spacecraft will simply drift out of alignment, its antenna no longer pointed at Earth, and the signal will fade into the cosmic background noise. When that day comes, when Voyager 1 finally goes silent, it will mark the end of an era. The spacecraft will continue its journey through the galaxy, but will no longer be able to follow along. We'll lose our eyes and ears in interstellar space. The data will stop flowing, the mission will be over. But until that day arrives, Voyager 1 is still out there, still fighting, still sending back messages from the darkness. It's battered, it's aging, it's falling apart piece by piece, but it's not dead yet. Not quite. Every morning, engineers point those massive radio dishes at a tiny, distant point in space and listen for that faint whisper. And most mornings, they hear it. The signal is still there. Voyager 1 is still talking. Is it alive, or is it a ghost? Perhaps it's both. Perhaps it's a ghost of the past, a relic from the golden age of space exploration, slowly fading away. But it's also still alive, still vital, still discovering, still teaching us things we never knew. It exists in that strange twilight zone between life and death, functioning but failing, communicating but corrupted, present but increasingly absent. And maybe that's appropriate, maybe that's exactly where Voyager 1 should be, balanced on the edge between what was and what will be, between the known and the unknown, between life and death, because that's what exploration has always been about. It's about pushing boundaries, crossing thresholds, venturing into that twilight zone where nothing is certain and everything is possible. Voyager 1 has given us nearly 50 years of incredible science and discovery. It's shown us worlds we never imagined and carried our message to the stars. It's outlived its design life by nearly a decade, survived challenges its creators never anticipated, and continues to function in an environment it was never meant to reach. Whatever happens next, whatever failures lie ahead, whatever silent darkness eventually claims it, Voyager 1 has already earned its place in history. But we're not ready to say goodbye. Not yet. So we keep listening, we keep hoping, we keep working to squeeze every last bit of life out of this remarkable machine. Because as long as Voyager 1 is still transmitting, as long as we can still hear its voice from the edge of interstellar space, a part of humanity is out there among the stars. And that's a connection we're not ready to give up. The answer to the question in our title, then, is complicated. Is Voyager 1 still alive, or are we talking to a ghost? It's alive, but barely. It's functioning, but failing. It's communicating, but the message is getting harder to hear. It's still there, still real, still doing science, but it's closer to the end than to the beginning. Perhaps in the end, it doesn't matter whether we call it alive or call it a ghost. What matters is that we're still listening, still learning, and still marveling at what this small machine has accomplished. What matters is that somewhere out there in the darkness, beyond the reach of our sun, beyond the edge of everything we've ever known, a tiny spacecraft built by human hands is still exploring, still discovering, still carrying our hopes into the unknown. And as long as that signal keeps coming, as long as we can still hear Voyager's voice across the vastness of space, a part of us is out there too, touching infinity,